Okay, so today's topic, we're actually going to review Math 10C. Okay, before we go on, we're going to review factoring, but a different kind of factoring. Okay, I have listed on this slide here, guys. I have listed on this slide here one way that you've learned to factor, which is how to factor a quadratic. And really, factoring means break things up into its parts. You could break up a quadratic into these two parts, but you can also just factor numbers. Right? And this is like grade, I don't know, 7 or 8, where you find the factors of a number. Like, for example, do you guys know that what I'm talking about here when I say the factors of 36 are all these values? Why is 5 not a factor of 36? Yeah, we often say 5 doesn't go into 36, which is another way of saying if you take 36 and divide by 5, it's not a whole number. Right? I mean, in theory, you can take 36 and divide by 5, but it's like 6.9324 or something dumb like that. So what we're looking to do today is just remind ourselves how to factor numbers. Hey, can you come back here in 20 minutes? As soon as I'm done working with these guys, I have to go deal with an issue in the office. Sweet, thanks. Or maybe I'm leaving right now. I don't know. Hello. Yeah. Okay. Just transfer me right here. Okay. Just give me a second, guys. Hello. Good. What's up? Okay. Yeah, that might be possible. Like I have the VC equipment in my room. Okay. Okay. That we can probably do. If I tell Shirley to call a quick staff meeting in my room, why don't we try to hook up by Google Hangouts? Because I did this all the time for my VC kids. You know how to use Hangouts? Okay. So why don't you shoot me a Hangout right after school, and I'll see that we can hook it up. And if not, then we'll try to call over the phone, and then we'll just do it over the TV screen like I do with calculus. Okay. Okay. Sure. I'll get them to. Well, we should probably do it right after school, like 3:35, 3:40. Okay. Okay. Thanks. Talk to you later. Bye. Hey, it's Chris calling back. Can you do me a quick favor? Can you shoot an email to all staff letting them know that we're gonna have a quick stand-up video conference staff meeting? Sterling has to chat with us about something. So I'm gonna in my room. Yeah, we're gonna use my calculus VC equipment so that we can do it kind of face to face. We're gonna do that like right away after school. So if you could shoot an email out, and then also can you do an announcement at the end of the day too? Just teachers tomorrow. Cool. Thanks. Okay. Bye. Okay. Sorry guys. Sorry, today might be scattered. There's an issue that has to get dealt with, but I can't talk yet. Okay, can we try this example if you guys haven't already? Okay. I'm looking for factors of 7. You're really just looking like what multiplies to give a 7 with whole numbers, and hopefully you guys know that the only numbers are 1 and 7. Because does 7 divide by 2? No. Does 7 divide by 3 or 4? Right? So hopefully you know your basic math facts. Like, for example, number 20. 20 divides by 1. 20 divides by 2. Doesn't divide by 3. Does for 4. In a way, you can almost pair these guys up, right? 4 went with 5. 2 went with 10. 1 went with 20. Okay, quick side note. How many factors would you have to have? How do I phrase this well? Can you have an even or odd number of factors? Even or odd number of factors? It would have to be even. Why would you have to have an even number of factors here? Because they always come in pairs, yeah. Does that make sense? Like when you're writing them out like this, they're always in groups of 2. Now, I guess that may not necessarily be true. Like if it was 25, you'd have 1 and 25, and then you'd have 5 and 5. So I guess in this case here, that's the same one. The point I wanted to make, though, is when you're looking for factors, always look for them in a group of 2, right? Because there's always 2 numbers that multiply to give the one we're searching for. Did I make that point well? So really, this is just a process of just kind of work through them. 60 would be, well, 1 goes with 60. 2 goes with 30. 3 goes with 20. 4 goes with 15. 5 actually goes with 12. 6 goes with 10. It doesn't divide by 7. It doesn't divide by 8. It doesn't divide by 9. And I would actually stop there because since 10 is the last one I already found, why would I bother going past that? So, quick question. Is this something you guys can more or less do? You guys feel comfortable with that? Like, this was not meant to be major review, but our goal is to be able to find factors. And I need you guys to be able to do basic multiplication division in your head to be good at this. Okay. One of the things you guys would have then learned last year, depending on who taught you, whether it was me or Miss Ashley, but you guys should have done a factor tree where you'd like say 48, and what you're going to do is you're going to find all of the prime factors. Okay? Prime factors are numbers that only divide by one of themselves. So like for example, yes, 48 breaks up into 8 and 6, but 8 can be broken up even into 4 and 2, and this 4 breaks up into those 2s. Anybody ever done this before? Okay, this is another task I might ask you to do, is break it up into all of the prime factors. So at the end of the day, 48 is really 2, 2, 2, 2, 3. Now, if I could, I wanted to show you that there's not one right way of solving this. For example, 48, sure, it gets broken up into 8 by 6, but could I not have made it 12 by 4? Would that not be valid? Well, let's follow this through. 4 then would be 2 by 2. 12 would be 4 by 3. This 4 is another 2 by 2. And look, at the end of the day, I still have 1, 2, 3, 4 2s, and a 3. So it doesn't really matter which order you do this in. Here's another picture just showing that basic concept here. I took 108 and I broke it up 3 different ways. Here it was 6 by 18 first, then it was 54 by 2, then 36 by 3. Really doesn't matter which one you do. At the end of the day, you get the same factors. All right, so let's try one more task here. Let's try to find all, not just the factors of these ones now. Let's try to find the prime factors. So, 15. What's up? Oh, they're in quantum. Okay. 15, what does 15 multiply to give? Well, 1 and 15, or 3 and 5. So, well, once I've done breaking this guy up into 3 and 5, you can't break up 3, right? 3's prime. You can't break up 5, so we're done. That one's hopefully easy. Okay, let's try 140. I'm sure there's got to be at least 7 different ways we can break up 140. We just need to pick one of them. How about 14 and 10? Well, then if I break up 14, it's into 7 and 2. 10 would be 5 and 2. So when you're done, I don't care which order you broke these up in, but here's one way you could write it. You needed 2 squared, a 5, and a 7. Do you guys see how I kind of rearranged this one here? Here I have a 2, here I have a second 2, so I called it 2 squared. And then you need 1, 5, 1, 7. In a way, you could like write the power of 1s there. There's one last copy there. Okay. Okay, let's try one last one here. Break up 390. I mean, again, there's lots of ways you can break it up. Quick idea. If it ends in a 0, though, it divides by 10. So divide it by 10. Use that as your first step. So 390, since it ends in a 0, why don't you break it up into 39 and 10? What does 10 break up into? That's easy, right? 5 and 2. What 39? 3 and 13. Can 13 be broken down any further? No, 13 is prime. Okay, so in this case right here, I guess, let's put them in order. We need 1, 2. We need 1, 3. We need 1, 5. We need 1, 13. That's our prime factors. Now, I am kind of rushing through this because ideally you guys have done this in the past, something like this, right? So even if you're falling behind, hopefully the only reason why you're behind is just because maybe I'm doing the math, like the division a little bit faster. But if you know how to do it, that's the more important part. Like, do you understand the basic concept? So the last thing I want to talk about today then is two terms you might have heard of before. We often give them acronyms. We call it either a GCF or an LCM, a greatest common factor or a lowest common multiple. And hopefully maybe you've heard these terms before as well. Let me show you some examples here. The greatest common factor between 12 and 16 is 4. And you guys already know how to do this because when we do factoring of polynomials like quadratics, that's the kind of factoring you do. Right? Like if I were to give you 12x plus 16, and I were to ask you, well, what's the biggest number in common between these two? You'd say, well, 4, because then you're left with 3x plus 4. Right? The 4 is the biggest number that both of these have in common. So I think you guys already kind of know this. Here's one way of figuring it out, though. If you were really stumped on how to find a greatest common factor, literally find all of the prime factors. So I've wrote them out here. 12 is 3 by 2 by 2. And 16 is 2 by 2 by 2 by 2. Yeah, I said that right. If you want to try to figure out a greatest common factor, then figure out what both of these have in common. So this one has a 3. Does this one over here have a 3? Okay. This one has a 2. Does this one over here have a 2? Okay. They both have at least one 2. This one here has a second 2. Does this one over here have a second 2? Okay, this one has a third 2. But did this first one have a third 2? And, well, then if there's obviously not a fourth one either. So when we're done, what was in common between both of them? Well, they both had 2 sets of 2's. 2 times 2 is 4. So 4 is the greatest factor that they both have. Because 12 divides by 4 and 16 divides by 4. Does that make sense? If you want to find the lowest common multiple, this is actually where we're getting larger numbers. Okay? A lot of kids, they struggle with the terminology. A factor is a piece, so factors should be smaller. Multiples are multiplying more and more. So if I ask you for a lowest common multiple, we're looking for a bigger number. But we're looking for a number in which 12 and 16 are both part of. Right? And in this example, it's 48. And sometimes the best way of solving this is literally just to make a list. 12 times by 2 is 24. If you were to make it like times by 3, it's 36. 12 times by 4 is 48. Like literally you can just write out a list of each of like the groupings. 12 plus 12 plus 12 plus 12. Or 16, literally all I'm doing here is saying 16 plus 16 is 32, plus 16 is 48, plus 16 is 64. And when you're looking for the lowest multiple, all you got to do is find the first number that's on both lists. So 12 is on this list. No, it's not there. 24 is on this list. It's not there. 36 is on this list. Hey, 48's on this list. There it is. Does that make sense? You guys have probably done this before. Let's just do a couple more examples and we'll call it a day. So let's find the greatest common factor between 90 and 225. And then in a second, we'll do the other one. I can already guess one number that's in common between them. I bet you there's a 5 in both of these numbers, right? Because clearly 90 should divide by 5 because it ends in a 0. And 225 can divide by 5. But, I mean, if you really want to figure it out, just break it up into a factor tree. Take 90 and bust it up. Take 225 and bust it up. So 90 could be, say, 9 by 10. Then this would be 3 by 3, and 2 and 5. Oh wait, 225. I believe 225 is 15 times 15, which then would give you a 3 and a 5. and another 3 and a 5. Everybody okay with that? Okay, so what do we do with these numbers? If we want the greatest common factor, we just got to figure out which ones are in common. Do they both have at least one 3? Okay, they both have at least a 3. Do they both have a second 3? Yeah, this one has a 3, this one has a 3. Do they both have a 2? According to this, no, they both don't have a 2. Do they both have a 5? So what's in common? They both had at least one 3. They both had at least a second 3. They both had a 5. 3 times 3 times 5 is 45. So here's what that means then. Can 90 divide by 45 and give you a whole number? Yeah, I can. Can 225 divide by 45 and give you a whole number? Yeah, I can. This is the largest number that is a factor of both. I'm sure some of you have already gone on and done the second one here. I'll just do it off to the side here. Let's break up 145 and 198. So, okay, this one's a bit more challenging. Let's see, 145. Maybe it divides by 6? Nope. Divides by 8? Oh, that's not the right number. Yeah, I'm hoping for something bigger than 2, but is that all it does? Okay, well, I'll do that. It breaks up into 2 and 77, and then 77 is 7 and 11. 7 and 11. Okay, 198, let's see, it probably divides by 2 to give 99. Okay, so 2 and 99. 99 is 9 and 11, and then 9 is 3 by 3. Okay, last question then. What do both of these numbers for prime factors have in common? Do they both have a 2? Yep. Do they both have a 7? No. They both have an 11. This guy has 3s, but this one doesn't. I think we're done. So therefore, the greatest common factor between these guys is 13, right? 2 and 11 is 13. We're multiplying 22. And here's an easy way to double check. I just want to make sure you guys aren't adding, because kids often add rather than multiply. So then double check. Does 154 actually divide by 22? Okay. And does 198 actually divide by 22? Okay. You guys feel like you can do that? I don't want to come off as rude, but this isn't grade 11 curriculum. I'm not even sure this is really grade 10 curriculum. Like this was, you did this before, you should have, so. But I always want to start with a really firm building block, because if you really struggle with this, radicals are hard. Oh wait, last question, then we're done. Lowest common multiples. Now, sometimes a good way of doing this is literally just start writing out a list. Oh. So like 5, 10, 15, 20, 25, 30, 35, 40, 45. Like I just start writing it out in groups of 5. And then 7, it's a little harder in groups of 7, but it's 7, 14, 21, 28, 35. And hey, look, 35's in common. Who's ever done it that way before? Like I showed you guys do that last way in grade 10, right? Okay. Let me show you another way of doing it. I'm going to do it for this next one here, though. Sometimes you can just make the lists because it's really easy. Like you'd go 10, 20, 30, 40, 50. This would give 30. Hey, look, there's the answer right there, right? And if it's drop dead obvious, that's great. But what happens if it's a little more challenging and then your list is like forever down? I want to show you a new trick I learned because I didn't even know how to do this until more recently. Still do prime factors. I want to do 10 and 15 again here. How do you break up a 10? Well, it's 2 by 5. How do you break up a 15? 3 by 5. Now, we're going to do a very similar thing that we did the previous time where we're looking for the smaller ones, the factors, when we do the multiples, only we change this one around. Here we want to make sure we get one of everything. Okay. See how right here there's a 2? I'm going to want a 2. See how right here there's a 5? I'm going to want a 5. See how right here there's a 3? I'm going to want a 3. See how right here there's a 5? I already have a 5, though. Make sense? Here there's a 2, so I'm going to write down a 2. Here there's a 5. I'm going to write down a 5. Here there's a 3. I don't already have a 3. But see here how there's another 5 again? I already wrote down a 5 from this guy right here. So don't write down a number a second time if it's already been used from the previous, like, factor. What is 2 times 5 times 3? 30. So you may actually find this useful when we try to do this last one here, because if some of you are, like, frantically writing out a list, I might beat you to it here. 10 is 5 by 2. 12 is 3 by 4, which is a couple of 2's. And 14 is 2 by 7. So if you guys are able to break them down into prime factors, make sure that you get one of everything. So, for example, the 10 is going to need a 5 and a 2. The 12 is going to need the 3. Now, see how the 2, there's already a couple of 2's right here? Since I've already used this 2 right here, don't use that one again. But see how there's an extra 2 right here? I'm going to need that one now. Now, this 2 right here, see, I've already used a 2 from this guy. I've already used a 2 from this one. So this 2's already been accounted for. The first 2 has already been used. Okay, like this guy, I've already written down his 2 right here. This guy, I wrote down his 2 right here already. And this one already has been used. But see how this guy has a second 2? That's why 2 made its way on the list a second time. This will be the lowest common multiple. 5 times 2 times 3 times 2 times 7. Whatever that is, that'll be the first number that's on all 3 lists. So I'll try one more of those just because some of you haven't seen that before. I didn't learn this until recently. It's a really nifty trick. Break up all the prime factors and then make sure that you get one off of each list. Okay, let me do another example here. Let's say that there was like a 2, a 3, a 5, then there was a 2, a 2, a 3, a 5, and then there was a 2, an 11, a 3, and a 7. Okay, this guy has a 2, so I'm putting it on the list. See how this guy has a 2 though? I've already used 1, 2 from each of them, so 1, 2 has already been used up for all of them, so I'm good there. This guy has a 3. I'm going to put it on the list. This guy here also has a 3, so that accounts, and this guy also has a 3, so don't count that again. This guy here has a 5, so I'm going to put that on the list. This guy here also has that 5, so I'm accounted for already. This 2 right here, though, see how this guy has the second 2? I'm going to have to put another 2 on the list. This first 2 right here came from this guy providing a 2, this guy providing a 2, and this guy provided a 2. So they've all provided 1, 2. But this guy right here is going to provide me a second one. This 3 right here came from this one, and this one. This 5 came from this one and this one. I'm also going to need to have an 11 and a 7. Whatever this is multiplied, there's your lowest common multiple. So it's actually a nifty trick. I used to literally just write out a list and keep going until I found the first one that was the same, and then someone showed me this. I was like, that's way faster. Can I do one more example of this and then we'll call it a day? I just want to make sure I don't lose you on this one. Okay, let's do one more. Let's pick 2 numbers that are really big, like say 320 and 72. If I were to write out a list one at a time, it would look like this: 320, 640, 960, blah, 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 blah. It's going to take forever, right? So first, let's break things up into the factors. 320 would be 32 times 10. This would be 4 times 8, 5 times 2. It'll be 2 times 2, 2 times 4. I blitzed through that pretty fast, but can you make your own factor tree? Like, maybe not as fast as I did, but do you know how to make a factor tree? Then on the other side, 72 is 8 times 9, 4 times 2, 2 times 2, 3 times 3. Okay, basically here's the rule. If you count it for one of the numbers, don't count it for the other one. Okay? So as soon as I count this guy right here, he has a 2. As soon as I count it for this one, I don't count that one anymore. This guy has a second 2. Okay, well that accounts for your second 2. This guy has a third 2. That accounts for your third 2. This one has a fourth 2. Okay, this guy doesn't have a fourth 2, but that's fine, I still count it. This guy has a fifth one, I still count it. This guy here has a 5. This one doesn't have a 5, still count it. This guy has another 2. Count it. Okay. Now, these 3 2s right here, I've already accounted for them because this one matched that one right here. This one matched this one right here. This one matched that one right there. So these 3 2s have already been accounted for. So then I need a 3 because this guy didn't have a 3. And I need another 3 because that guy didn't have a 3. So whatever this is the lowest multiple between 320 and 72. So 2 times 2 times 2 times 2 times 2 times 5 times 2 times 3 times 3. I got this. Anybody else get 2880? Yeah. Okay, here's how I can check, by the way. Take 2880 and divide by 320. Okay, the 9th number on the list would have been this one here. So if I did the list, I would have had to at least go 9 numbers deep here. If I took 2880 and I divided it by 72, it would have been the 40th number on the list. Now, don't get me wrong. If you want to make a list that's 40 numbers long until you find the first one in common between both, you totally could. But as soon as someone showed me this, I was like, that is brilliant. So, did that make sense? So, quick recap. I need you guys to be able to do factor trees, which I think you've all done before. I blitzed through a few examples here. Okay. Using factor trees, though, you can do 2 things. You can find a lowest common multiple, which basically means include everything that's in both sides, but like if there's a 2 on both, don't count it twice. Okay. You can also do the factors, and the factors basically would mean then, where do we do one of those? The factors would be similar in that you got to count the stuff that's only on both lists. So here there was a 3 on both lists, I count it. Here there's a 3 on both lists, count it. There's a 2 on this list, but not on this list. Don't count it. You see how they're almost opposites of each other? In one of them, you only count what's on both lists. And in the other one, you count everything, but don't repeat the stuff that's on both lists. Okay, you guys have any questions? Okay, cool. Tomorrow we're also more or less doing some review as well. We don't really get to new stuff until next week. So why don't I give you guys the last 40 minutes today to finish up stuff. So quick reminder then, if you haven't finished your test, you can do that first. Otherwise, what I'd like to do is take skills journals and assignments. Can they all be done by Friday, please? Does that work? Cool. Okay, I gotta go down to the office now. So you want to watch these guys here? Okay, and unfinished tests are sitting here somewhere. Yeah, sorry, I went a little longer than I wanted to. Yes.